At the stroke of midnight on October 1st, 2025, NASA's homepage suddenly went dark. It was replaced by a blank white screen and a single, cold message due to a lapse in federal government funding. NASA is not updating this website. Millions of followers were stunned as a universe of information vanished. No more images, no press releases, no social media posts, and ironically, at that very moment, hundreds of millions of kilometers from Earth, an interstellar visitor had just entered the prime Mars observation window, 3I Atlas. A once-in-a-lifetime opportunity to see a piece of another star system up close, as NASA was forced into silence. The world could only stare at a dark screen while orbiters continued to quietly gather data. The question arose, was this just a bureaucratic coincidence? Or was a colossal secret being hidden from public view? The story begins on July 1st, 2025 at the Atlas Observatory in Chile. This robotic telescope system, funded by NASA and operated by the University of Hawaii, scans the entire sky several times a night, hunting for asteroids that could pose a threat to Earth. During what seemed to be a routine observation, the Atlas computers flagged a small, faint point of light moving unusually against the background stars. At first, it looked like thousands of other new objects detected each year. But when astronomers calculated its trajectory based on the first few measurements, they were stunned. Its path wasn't a closed ellipse, like every other object bound by the sun's gravity. It was an open-ended hyperbola. Every new measurement only solidified the conclusion this was no ordinary asteroid. It was a visitor from outside our solar system. Over the next 3 months, from South America to Europe, from North America to Asia, observatories joined the chase. They recorded precise coordinates, measured its brightness over time, collected spectroscopic data, and sent it all to the Minor Planet Center for analysis. The evidence piled up. And finally, the verdict was undeniable. This was the third interstellar object ever confirmed by humanity. Officially designated 3I Atlas. The name 3I for third interstellar object immediately brought to mind its two mysterious predecessors. In 2017, Oumuamua appeared as an astronomical puzzle, an unusually elongated object, perhaps up to 400 meters long, that accelerated non-gravitationally without any visible dust or gas. It sparked endless debate, with theories ranging from a giant nitrogen iceberg to an artificial probe. 2 years later, in 2019, 2I Borisov was discovered by amateur astronomer Gennady Borisov. This one looked more like a traditional comet, with a clear coma and tail, but it contained a concentration of carbon monoxide many times higher than normal, suggesting it was born in a radically different and colder environment than our own solar system. With only 2 data points, scientists couldn't say which was typical. 3 Atlas, therefore, became the deciding vote, the third piece of the puzzle that could reveal the true diversity of matter in the Milky Way. To picture the scale, 3I Atlas was traveling at over 200,000 kilometers per hour. Initial estimates suggested its nucleus was as large as a football stadium hundreds of meters across, tiny compared to a planet, but colossal for a chunk of ice that has wandered for billions of years through interstellar space, only to now skim past our neighborhood. Imagine it an ancient rock, born from a distant protoplanetary disk billions of years ago, now straying into our solar system and gliding just past the orbit of Mars. That is 3I Atlas. What made this event so special was not just its rarity, but its trajectory. In early October 2025, 3I Atlas passed within approximately 30 million kilometers of Mars. In astronomy, that is an incredibly precious distance. The fleet of orbiters around the red planet could observe it from a much closer vantage point than Earth. From October 1st to the 7th, the entire international team was ready. NASA's Mars Reconnaissance Orbiter and MAVEN, Europe's Mars Express, and ExoMars Trace Gas Orbiter, China's Tianwen-1, and the UAE's HOPE Orbiter all turned their sensors toward the target. High-resolution cameras, infrared and ultraviolet spectrometers, plasma and magnetic field detectors. Instruments designed to study Mars had now accidentally formed a temporary interstellar observatory. This was humanity's only chance to get an up-close look at a fragment from another star system. to capture every photon of light, every molecule of gas escaping from its ancient ice. And yet, just as this window opened, the most familiar voice in space exploration went silent. Because the US government failed to pass a budget, the Anti-Deficiency Act was automatically triggered, forcing NASA to cease all public communications. The website showed an error message. NASA TV stopped broadcasting. Social media accounts went dormant. And the press office was closed. Over 18,000 employees were furloughed without pay. Only the essential engineers operating the multi-billion-dollar spacecraft were allowed to keep working, silently protecting the assets as they flew. As 3I Atlas swept past Mars, the public saw only a void of silence. But inside mission control centers, data was streaming in every second. To understand what scientists were looking for, imagine you're standing on the side of a road as a strange car speeds by. You can't see the license plate or who's inside, but you can hear the engine, see the reflection of its headlights, and guess its speed. Astronomers do the same with 3I Atlas instead of seeing the object directly. They read the indirect clues it leaves in its light. First is the light curve, a graph of its brightness over time. If 3I Atlas is spinning, its brightness will increase as a reflective side turns toward us, then dim as a darker side faces away, much like the flash of a water bottle rotating in the sun. From this rhythm, scientists can deduce its rotation period and approximate shape. Is it round, irregular, or elongated? It was this method that led them to suspect Oumuamua was shaped like a giant cigar. Atlas would soon reveal its own profile. Next is spectroscopy, splitting the object's light into its constituent colors to find chemical fingerprints. As a block of ice is heated by the sun, it releases water, carbon monoxide, or carbon dioxide. Each gas leaves a unique signature in the spectrum. If they detected methane or complex organic compounds, it would be evidence that Atlas formed in a carbon-rich environment, perhaps one linked to the building blocks of life. Think of Atlas as a cosmic snowball. As it melts, it reveals the flavor of its birthplace. Beyond light, there was another invisible layer of information-plasma interaction. NASA's MAVEN and China's Tianwen-1 could measure how the solar wind, a stream of charged particles moving at hundreds of kilometers per second, collided with the faint gas clouds surrounding Atlas. It's like dropping a block of ice into a rushing river and observing the eddies and ripples to learn if the block is hard or soft. A thick plasma cloud around Atlas would indicate it's highly active and outgassing heavily. A thin or unusual cloud might be a sign of something strange. Instruments from the European Space Agency, especially on the ExoMars Trace Gas Orbiter, were so sensitive they could detect trace gases at parts per billion levels. This means that even if Atlas exhaled the tiniest wisp of vapor, it would be recorded. This was the data the global scientific community was waiting for, as it could distinguish whether Atlas was an icy comet, a dry, rocky asteroid, or something never seen before. Why do these details matter so much? Because with every interstellar object, we aren't just observing a rock, we are seeing the history of a distant star system. If Atlas is rich in ice, it suggests that planets in its home system may have formed in a cold region. If it's rich in metals or contains strange compounds, it would challenge current theories of how star systems evolve. And if there are signs of complex organics, it would hint that the seeds of life may be scattered across the galaxy, seeding any planet lucky enough to have the right conditions. Remember, in all of history, we had only two prior observations of interstellar objects. One was an anomaly, Oumuamua, and the other, a pristine comet Borisov. Atlas was the tiebreaker vote. It could tip the scales in one direction or open up a completely new one. This is why every photon, every curve, every spectral line in the data was treated like gold by scientists. The irony was that as this priceless data quietly streamed in, the public heard only scattered rumors while social media erupted with speculation. NASA's silence widened the gap between science and the public. But science doesn't stop for a political wall. It keeps running, just as 3I Atlas speeds forward on its hyperbolic path. And when the first results are finally revealed, They might just shock the world because what Atlas brings is not just data, but perhaps a piece of a puzzle that will force humanity to rewrite its understanding of the universe. But the most important question remained unanswered when scientific truth is delayed. Who fills the vacuum, researchers? Or wild theories? That vacuum did not wait long to be filled. With NASA silent, social media became the main stage. Hashtags exploded: Atlas Blackout. Where is Atlas? Mars window. People shared composite images, analysis videos, and bold theories. Some claimed Atlas was carrying an artificial signal. Others insisted an unusual spectrum had been suppressed. Still, others argued the whole thing was just a bureaucratic coincidence, a cruel joke of history. Every gap in information became fuel for the imagination. In the public eye, silence is more terrifying than any denial. When there is no official voice, any story can become truth to those who want to believe. This time, scientific fact was forced to take a back seat to theories that were more compelling and easier to share. An administrative decision in Washington, D.C. had accidentally become a launchpad for conspiracy theories that spread globally. This exposed the fragility of scientific trust in the 21st century. Science relies on data and transparent processes. But in the age of social media, a single day without updates is enough to ignite a firestorm of doubt. When the world's most trusted source of information, NASA, suddenly went dark, the public didn't see a legal process. They saw a cover-up. And even if the data were later released in its entirety, the seeds of suspicion, once planted, would be difficult to remove. But here lies the paradox: while NASA was silent, its international partners spoke up. The European Space Agency in Darmstadt, the Tianwen-1 team in Beijing, the Hope mission in Dubai, names that often stood in NASA's shadows suddenly became the primary sources of updates. News reports from Europe, China, and the UAE were quoted heavily, for the first time pushing NASA out of its monopolistic hold on information. To many, the event felt like a shift in soft power space. Science was no longer just an American story, but a global game where anyone could lead the narrative when the opportunity arose. From a scientific perspective, the Atlas data is invaluable. It can not only test theories of planet formation, but also help answer the question: does life share common ingredients? Sown across the galaxy, but from a societal perspective, Atlas presented another challenge: how do we receive truth when it arrives slower than rumor? Would a simple discovery that Atlas is a normal comet be enough to extinguish millions of shares about an alien probe? Or would the scientific truth be drowned out by the noise of social media? No matter how clearly it was recorded in spectra and graphs, the 3i Atlas event thus became a test not only for astronomy, but for the public's faith in science itself. It revealed a paradox: a single administrative decision, a line of text on a website, was enough to completely alter how the world perceived a cosmic discovery. And it raised a larger question: do we need an international mechanism to ensure that discoveries essential to humanity cannot be blocked by political borders? In the information blackout, one thing became clear: the universe does not wait for human schedules. 3i Atlas passed by, the data was recorded, and the truth lay waiting in the numbers. But at the same time, the event proved that how we communicate science is just as important as the discovery itself. When silence persists, imagination fills the void, and sometimes that imagination is more powerful than proof. And that is the greatest challenge: how to ensure that when the truth is finally revealed, it isn't buried by the wild theories that have already taken root in the public mind. A comet may just be a comet, but in the silence between data and disclosure, it can become anything, even a messenger from humanity's own imagination. Right now, 6 explanations are circulating. Some believe it was all a bureaucratic coincidence, a dry law that just happened to obscure a rare cosmic moment. Others point to natural interference, like solar wind or the Martian atmosphere, distorting the signal. A third group leans toward the theory that Atlas is an unusual natural object, perhaps a rare metal-rich nucleus, a nitrogen iceberg, or a type of massive rock never seen before. Then there are the more extraordinary ideas: the possibility of a secret scientific campaign, where the most sensitive data is being held behind closed laboratory doors. And further still, the theories of an unknown technological influence interfering with the object, or even that Atlas is not natural at all, but a disguised artificial structure. To fight this flood of speculation, the scientific community relies on a strict verification framework. Any claim must pass a series of key questions. Was the signal confirmed by multiple independent instruments? Was it recorded by different spacecraft? Can it be explained by any known natural phenomena? And most importantly, will the raw data be made public for everyone to analyze? Only after clearing these hurdles can an anomaly move from the realm of rumor to scientific fact. So far, all public data points to a smooth, hyperbolic trajectory and familiar cometary behavior. But the door remains open. Much of the data is still undeciphered. NASA remains behind its legal wall, and many crucial announcements have yet to be made. Atlas, therefore, is more than an astronomical phenomenon. It has become a mirror reflecting both science and humanity. On one hand, it showcases the power of the scientific process, patient, rigorous, and evidence-based. On the other, it exposes the public's thirst for instant answers, where imagination fills the void faster than any data can. A comet may just be a comet, but in the silence, it can become anything: a hidden mystery, a strange technology, or even a message from a distant civilization. And this is where the story needs you. As an observer, which scenario would you choose to believe: a mundane coincidence, or an extraordinary possibility waiting to be proven? Will you side with the patience of science, or will you let your imagination lead the way? Share your perspective, because your answer will not only shape how we remember 3i Atlas, but also reflect how humanity confronts the great silences of the universe.